Hello everyone, today we are going to discuss about how the voltage is getting to be divided among the resistors in a series circuit. So here this is a series circuit in which we have connected two resistors in series and let the resistance values be R1 and R2. When two resistors are connected in series, here the voltage is getting to be divided whereas the current will remain same. And I am taking the value of current as I. Applying KVL, according to KVL, the sum of voltage rises is equal to sum of voltage drops. Here the voltage across the source is taken as voltage rise. Therefore, V is equal to sum of the voltage drops. The drop across the resistors is taken as I into R. Therefore, the voltage drop across R1 is I into R1 plus voltage drop across R2 is taken as I into R2. Taking I as common, I into R1 plus R2. Therefore, I is equal to V by R1 plus R2. Once we have calculated the value of current, then we are going to find out the drop across each resistor. The voltage drop across resistor R1 is equal to I into R1, which is equal to V by R1 plus R2 into R1. And voltage drop across resistor R2 is I into R2 and the value of I is V by R1 plus R2. Therefore, V by R1 plus R2 into R2. Therefore, from these equations, we can conclude that the voltage drop across any resistor in a series circuit is equal to the ratio of that resistance across which we are going to find out the voltage drop to the total resistance. The total resistance is nothing but the sum of the resistances multiplied by the source voltage. Now let us consider an example. Find the voltage across each resistor shown in the figure. Here three resistors are given and those are R1, R2 and R3. And we need to find out the voltage drop across each resistor by applying voltage division rule. So according to voltage division rule, the voltage drop across any resistor is equal to total voltage. The total voltage what it is given is 60 into the resistance value across which the voltage drop has to be found out. Here I am going to find out the voltage drop across R1. Therefore, I am going to write it as R1 by total resistance. The number of resistors that are connected in series are R1, R2 and R3. Therefore, total resistance is equal to sum of resistances, that is R1 plus R2 plus R3. So, substituting the values, 60 into resistance value 10 by total resistance 10 plus 20 plus 30, that is equal to 10. When we want to find out the voltage drop across resistor 2, the formula is total voltage, that is V, into the resistance value, that is R2 by total resistance. Therefore, we can write the formula as VR2 is equal to V into R2 by R1 plus R2 plus R3, that is equal to 60 into 20 by 10 plus 20 plus 30, which is equal to 20 volts. Next, we need to find out the voltage drop across 30 ohms resistor. So, the formula is total voltage, that is V, into resistance value R3 by sum of the resistances, that is R1 plus R2 plus R3. Therefore, the formula is VR3 is equal to V into R3 by R1 plus R2 plus R3. Therefore, VR3 is equal to 60 into 30 by 10 plus 20 plus 30, that is equal to 30 volts. So, this is about how the voltage is getting to be divided among the various resistances which are connected in series. Thank you.